Okay, good morning, class. This is Mr. Bean. I hope everyone here had a good spring break. I want to start off by saying that I do miss you guys, and hopefully, we can touch bases in the future here. But anyways, here I want to talk about the next assignment here. This is the follow-up lab to the Socratic questions about lenses. And here is some reading here. I'll let you go ahead and read this here. I don't want to spend too much time on this, but I do want to go ahead and take a look at lenses here. So here we have a lens, and there's converging lens. There's also diverging lens. Okay, and let's take a look at those lenses here. So converging lens was a little bit thicker in the middle, and diverging lens are thin in the middle. Okay, but let's go ahead and focus on the converging lens for right now. So a couple of things of note here. Let me go ahead and get a pencil out here. Let's annotate this. This here is the focal length. Okay, this is where all the rays focus at one point. Here's a focal length here. Each one of these blocks, I believe, is 10 centimeters. Let's go ahead and write down 10 centimeters here. Okay, get it right here. And so there's a focal length here. There's also a focal length here. Now this here is the object. Okay, we're going to put here O for object here. And this distance here from the center of the lens to here is what we're going to go ahead and call distance of the object here, okay? And notice there's a certain height here. So we'll go ahead and call that HO, and that will be what we call the height of the object. All right, so we want to do some ray diagrams like we did for mirrors. So the first type here is, so here we have the first mirror here, or the first ray diagram. This is the principal axis right here. It goes to the center of the lens. The first one we want to do is go ahead and kind of draw this one here. That will be the first one here is parallel until it hits the mirror here, or the center of the lens, and then it goes through the focal point like so, okay? And the next one here goes through the origin and try to make it as straight as possible. It goes through here. And the third one, if you want to do a third one, hold on, let me backtrack here. Let me do something real quick here. Okay, no, we're good, we're good. The third one here goes through the focal point here till it hits the mirror, like so, and then it goes like that. And it meets up right here. And over here, this will be the distance of the image right here. And this is height of the image, which will be HI. That's the height of the image. And notice that the image is inverted. So inverted images are normally going to be real images that can be projected onto a screen. So if we had like a movie theater, like a film screen, let's say this was a screen, this image could be projected on this screen right here. Okay. Anyways, let's go ahead and go back to mouse. So that's how we do the ray diagrams. Now, let's do it a little bit more better. And let me go ahead and use the same picture here. Now, there's a simulation here that you can use. And so usually what we want to do is draw the first ray, which is parallel to here and goes through the focal point and goes right here. That's the first ray we want to do. And the third one we want to do is one that goes through the origin here and meets up right here. You probably could stop right here and draw your image here. But if you want to do another ray, it would go through the focal point, hit here, and then go parallel. And where all three rays meet up is where you would draw the image. Okay, that's if you wanted to do all three of them. Okay, all right, let's go back to here. So this is for a converging lens here. And I'll let you do some more reading here about the magnification and what's going on over here. Let you read that. There's some online resources that you can do here. One would be, there's this online calculator here where you would enter in just like the mirror, you would enter in object distance, image distance, and get the focal length, or you can use this to if you have two of the variables, you can solve for the third one. Okay. Another thing we have here is the lens simulator. You may want to use this. This may help you out in case you need to do some things here and play around with this. This might help you with some of the ray diagrams you're going to do. So that's the theory here. So as we go down here, there's going to be some data here. Here's the trials that we're going to be doing here. And so the first one here is that you want to draw a ray diagram. So on a separate sheet of paper at home, I'm going to give you what the focal length is and what the distance of the object is. So try to draw this as best as you can. And so I give you that focal length is 5 centimeters. Object distance of the object is 10 centimeters. Just use some graph paper or copy and paste from online. And I want you to determine the DI and the magnification. Draw the ray diagram, show me where the image shows up. Calculate or determine what DI or M is. You can use the equation or you can do it from the picture here. And is the image real or virtual? So this is, each one of these will be worth 10 points. So this would be trial 1, here's trial 2, trial 3, this will be trial 4, and here's trial 5, okay? And then trial 6, now if you can, use your Chromebook to take a picture and copy and paste or insert the screenshot of your solution on paper into the yellow box. And finally, part 2 is going to be the lens simulation here. Go ahead and click on this here, and this will pop up here, and it's going to ask you to, here's this, gives you some information here about the focal length, the height, distance of the object. And it's going to ask you to determine the location and height of the image, just like we did for the mirror. All right, that should be able to get you kind of caught up here or explain what's going on. When you are done, go ahead and submit it to me, and that'll be it. Until next week, you guys take care, and hey, love you guys 3,000. Okay, bye.